Okay, I'm sorry. We will practice hypothesis testing. You hearing me
Okay.
now? All right. And I will use one of your homework assignments to practice and illustrate hypothesis testing. All right?
Okay, understood.
All right. I will share a file. See my screen? Yeah. Load the file again.
Take your time.
Okay. So you can see my screen. Am I correct? Hello? Hello? Hello?
I'm here. I'm sorry. I'm here.
Okay. You can see my screen?
Yes, I can.
Okay. Here it says, test the hypothesis that the average price per square foot in waste layer is less than 325. But I'm going to test hypothesis in two ways. Okay?
Okay.
Okay, I'm going to test it in two ways. There is something called a two-sided hypothesis. There's also something called a one-sided hypothesis. Okay? Now,
Two-sided hypothesis, one-sided hypothesis. Understood.
yeah, okay. Now, in a two-sided hypothesis, what you are testing is that the average is equal to or not equal to. For example, here, I'm going to test the hypothesis that the average price per square foot is equal to 325. All right?
All right.
That is a two-sided hypothesis. Then I'm going to test the hypothesis that the average price per square foot is less than or is greater than. Okay? Now, so first of all, we ask the question, what is hypothesis testing? What is hypothesis testing? Okay? Now, hypothesis testing, what it is you ask yourself the question, you state a hypothesis. Okay? For example, you state a hypothesis that the average price of houses or the average price per square foot is equal to something. That's your hypothesis. Okay? You make a statement and a claim. Make a statement and a claim that a certain um, variable has a certain characteristic, or a certain population. Actually, it's about the population. You make a claim and a statement that a certain population has a certain characteristic. For example, the population of students that attended school today, um, it, the students that attended school today is a population. Okay? The students that attended school today is a population. And so you make a claim that the average travel time to school today was 30 minutes. You make a claim that the average student that attended school today has an income of a certain amount of money. You make a statement and a claim that the average professor uh, has an income of so and so. That's a claim, okay? So that statement and a claim that the population of, say, professors, of students, of babies born in the hospital today um, has the average weight of 7 ounces, okay? Or seven
Okay.
pounds, not 7 ounces, of 7 pounds, okay? So that is a statement and a claim. So the hypothesis is a statement and a claim that a population has certain characteristics. For example,
Mhm.
the population of professors in the school, okay? The population of professors in the school, or the population of students that attended school today, okay? Population of students that attended school today, okay?
Okay.
Has certain characteristics. That's a hypothesis. And that characteristics will be the average expenditure on lunch, the average income, okay? The average time, travel time to school. That is a characteristic, okay? All right. Uh, Here we are testing hypothesis for average, okay? And so we state what we call a null hypothesis, okay? Null hypothesis, and we state that null hypothesis as H0. Null hypothesis, and the null hypothesis is that the population mean, usually mu, is equal to some value, okay? So I'm going to make this big.
Okay.
Mu, okay? Mu is equal to some value. For example, I'm going to state it in general. And we call it mu naught, okay? Mu naught. For
Okay.
example, we can say that mu is equal to 10. We're saying that the population average is 10. That's a hypothesis, all right? Population average is 10. And then we state what we'll call alternate hypothesis.
Alternate hypothesis. Mhm.
Alternate hypothesis is, for example, I'm going to take my time. Alternate hypothesis is that mu example, that mu is not equal to 10. That is the alternate. Okay.
Okay, understood.
The null hypothesis is that mu is equal to 10. Right? In general, we say mu is equal to mu naught. So whatever we put there as mu naught, for example, here, mu is equal to 10. The alternate hypothesis is that mu is not equal to 10. This is what we'll call a two-sided hypothesis.
Two-sided hypothesis.
A two-sided hypothesis. Two-sided hypothesis. It's either 10 or it's not 10. All right? All right. Now, we have what we call the one-sided hypothesis.
One-sided hypothesis.
One-sided hypothesis. Now, the difference between a one-sided and a two-sided hypothesis is that we said that mu is equal to 10, and the alternate will be that mu is less than 10.
Mhm.
So there's a strict inequality. The alternate could be that mu is less than 10 or that mu is greater than 10. All right? That's we state it either way. You could state it either way. That mu is greater than 10 or that mu is less than 10. You get it?
Okay, got it.
Okay.
So that would mean that the null hypothesis for the null one-sided hypothesis would be like mu is less than or greater than 10, or
The null is that mu is equal to 10. It's always the strict equality equality sign is on the alternate. Okay? On the
okay.
alternate. Now you can actually state the null to be that mu is equal to or greater than 10. Okay? But I just usually prefer to say that it's equal to 10. Okay? And the alternate has the strict inequality sign, which is that mu is less than 10, or you can state it that mu is greater than 10. Now, what will inform or what will make you state the inequality as less or greater than 10? Now, now the rule is very simple. When you are doing a hypothesis testing, you're essentially doing what we call inferential statistics, which is to say, you use information from a sample to make an inference or to make a decision about the population. Because when you're doing a hypothesis test, essentially what you're doing is that you do not have the information about the population. Because information from the population is the true characteristic. For example, if you knew everything about the amount of money that professors spend on lunch, if you have all the information, if you can identify the entire population of professors that could ever exist, and you calculate the average, then what you would then have is the population information, which is mu, the population mean. If you knew all the professors and you can calculate their average, then you have the true value of the mean. But if you don't have that information, then you take a sample. And so that sample provides you some information that you would use to make an inference. And so what you're testing from a sample is a hypothesis. Okay? All right. So in this problem, we test the hypothesis the average price per square foot in waste layer is less than 325. Now, let us look at our sample information, average price per square foot. This is average price per square foot. Make it bold. And this is the sample information that we have. Okay. No, we're looking at waste layer, price per square foot. So we have our sample information to be 194. This is the sample information we have. Okay? Because the sample is the sample average, the sample mean is 194, it makes sense to ask ourselves whether the true population mean is actually less than 325. You get the idea, okay? It wouldn't make sense for us to start testing whether the true population mean is greater than 325 when the sample has already given us an information, right? Okay. Now, suppose we were testing for Mariners Harbor. Going to paint Mariners Harbor. Suppose we were testing for Mariners Harbor. You see that the sample average for Mariners Harbor is 305. That could simply be a sampling outcome. It might actually be that the true population price per square foot for Mariners Harbor could be 325. It could be even more than 325 because you can see that 305 is not too far from 325. Okay? But because the sample information has already indicated to us that it might be less than 325, we will test the hypothesis that the true average is truly less than 325, but statistical testing could lead us to conclude that it is not less than 325. Okay?
Okay.
Okay. So I'm just going to try to make this easy for us to understand. Okay. Hmm. How then do you go and test a hypothesis? Okay. Now, what is your objective when you're testing a hypothesis? The ultimate objective is to reject the hypothesis or not reject the hypothesis. And when you do not reject the hypothesis, what you're actually just saying is that you do not have the sufficient information to reject the hypothesis, right? So let us then proceed. Here, our null hypothesis is that mu, and I'm going to our null hypothesis is that mu is 325. That's our null hypothesis, which is to say that the average price per square foot is equal to 325 or more. All right. That is our null hypothesis. The average price per square foot is equal to 325 or more. And the alternate hypothesis is that mu is less than 325. That is the alternate hypothesis. Okay, which is that average price per square foot is less than 325. And so now we state the level of significance. Okay, we state the level of significance.
Yeah.
All right. The level of significance is 2.5%. Okay, that is to say, what we'll call the alpha alpha is 0.025. Okay, we state the level of significance. Right? We state the level of significance. I'm going to create space here. The level of significance, which tells us that there is a 2.5% probability that we could be wrong. Right? It says that there's a 2.5% probability that we could be wrong. So now, once you state that, you use the standard normal distribution table to select what you call the Z statistic that enables you to reject the null hypothesis. And so I'm going to, okay, which implies, this is, okay, that we get a Z table. What is the Z value? And the Z value for this is what? So for now, I'm going to stop share this and get a z value. Okay. Now, what it simply says, what the z value simply says is that the area under the normal distribution uh, for a 2.5% error is equal to what? Now, if there's a 2.5% chance that you're going to make an error, they're going to make a mistake, okay, that could be wrong. Whereas, let us look at the normal distribution so that I'm going to share the normal distribution. This is the normal distribution table. You can see that the area of the normal distribution here, the entire normal distribution, the area is 1. The mean value of z is 0 with a standard deviation of 1. So if 2.5%, each side of the normal distribution is 50%. Each side of the normal distribution is 50%. This left side has an area of 50%, and the right side has a total area of 50%. Now, if 2.5% is on this side, that is to say, there's a 2.5% chance that you're going to be erroneous. And so that means you're going to be on the tail end of the distribution here on this tail, and that means that 2.5% will be on the white side, right?
Right.
If 2.5% is on the white side and the area on this right side is 50%, that means that there's a 47% chance on the interior. That is from 0 to where you begin to look at your 2.5%. Okay? And so 47.5% there. So now the z value will be 1.9 and going all the way here to
0.06?
Yes, 0.47, no, 0.475, because it's 47.5% is going to be on the interior. Because if you take away 2.5% from 50%, you're going to have 2.5%. You're going to have 47.5%. Am I correct? You take 0.5 minus 0.025. What do you get? You get 0.475.
So for
Okay?
1.9 and
0.06.
0.05, I see 0.4744.
Fine. No. Remember, you're looking at 0.475 because you're taking. If you take away if you take away 0.025 from 0.5, what do you get?
Okay,
you get 0.475.
It would be between 1.9 and 0.06.
That's correct. So that means you're looking at 1.96. The z value will become 1.96.
The z value would be 1.96.
That's correct. Okay?
Okay.
So then 1.96. So let us go back then to how we proceed. Okay? And so the z value will be 1.96. Okay? Our z value will be 1.96. That is how we okay? And so we standardize So what we do now is we standardize the value and we calculate Z, and the calculation of Z simply says to us how far away is our sample mean from the hypothesized true mean. How far away? If we are too far from the hypothesized mean, then we reject the null hypothesis. Okay?
Okay.
Okay. We reject the null hypothesis. So we calculate a Z value which tells us how far away we are, and the Z value will be the sample mean, which we will call X bar. Okay. I'm going to call it X bar minus the hypothesized mean. We take that.
Wait, this would be represented by Z star, right?
This is the Z star.
This is Z star. Z equals 1.96.
Yes.
Oh, so the
No,
other
no,
one is
Z star is 1.96. Thank you very much for bringing that up. Okay.
right. Sorry, I initially
Okay.
got a bit confused. My bad.
Okay. No. There's nothing bad about it. Okay.
Okay,
Z star is 1.96 because that is the hypothesized Z. Okay.
got
And
it.
we're asking, okay. So the sample mean, okay, the sample mean, which we call X bar, divided by the sample standard deviation, okay, the sample standard deviation, which is the S, okay, where S equal to sample standard deviation, okay. And in that case, what do we have? What we have is that our Z is equal to the
So
sample mean, which is here 194.35,
194.
minus the hypothesized, which is 325, the sample, the hypothesized population mean, okay, divided by the sample standard deviation, 50.879, 50.879. That is our Z, okay? And we have a decision rule. We have a decision rule, which is that if the calculated Z is greater than or equal Z star, we reject the null hypothesis.
So if Z is greater than Z star, reject the null hypothesis.
Yes, we reject the null hypothesis. But if
So if Z is greater than or equal to Z star, we reject the null hypothesis.
But if Z is less than Z star, we cannot reject
Okay.
the null hypothesis.
Okay. I think I get it now.
You get it?
Yeah.
Okay. So now, what is our calculation? What is our decision?
4.35 minus 32.
Our decision. Z is equal to, so let us calculate that Z.
Okay, so for Z, I got negative 2.5678577073 or negative 2.57.
325 minus 194,
Right.
35 over 50.879, 50.879, 2.568, okay? 2.568. That's what I get. All right?
Oh, I got a negative 2.568.
Right. Use the
Okay.
absolute value. You use the absolute value.
Oh, right, got it. So automatically goes to absolute value, which is positive. My bad. Sorry, I keep getting my bad.
Nope, nope, it's not bad. Okay? This is what we'll have to explain. Okay. You use the absolute value to test the hypothesis. All right?
All right.
And so Z is equal to 2.56. And so since 2.568 is greater than 1.96, that means we reject the null hypothesis. We reject the null hypothesis.
Mhm, mhm.
At the average price per square foot is equal to 325 and conclude that average price per square foot, average price per square foot is less than 325. So once we reject the null hypothesis, our conclusion is the other side. Okay? We reject the
Okay.
null hypothesis that the average price per square foot is equal to 325. We remember that was our null hypothesis. Right?
Okay.
And so our conclusion is the alternate, that the average price per square foot is less than 325.
Got it. So
You get the point.
yeah, so reject the null hypothesis and conclude that the average price per square foot is less than 325.
It was our alternate.
Yeah, right.
Okay. So, so the method of hypothesis testing is clear. Suppose you had a two-sided hypothesis, which simply says that the average price per square foot is 325, and the alternate is that the average price per square foot is not 325. All right? Then once you reject this null hypothesis, you are simply saying that the average price per square foot is not 325. You are not saying it is greater. You are not saying it is less. You're simply saying it is not, if you had a two-sided hypothesis. Sometimes we have a two-sided hypothesis when we have no idea what it is, or if our objective is to reach a certain conclusion that it is less than 325 for whatever reason, okay? It could be a policy reason. And we simply say the average price per square foot is less than 325. That's what we need to understand in order to make a policy decision. Okay. So this takes you through hypothesis testing. And you can now do the rest of the homework assignment. If you felt you did it wrong, you can request a redo. Now, remember, I did not do all of it. Okay, if you look at the entire homework assignment, it goes beyond this. But you can apply the method that we have here, we have explained here, to answer the rest of the questions. You get the idea?
I see it.
Okay, all right. So do you have any other questions?
Um, not right now. No.
Okay. You can always send me an email. You can always request a Zoom session at for your convenience, and we can work out something that is mutually convenient, and we go through explanation. All right?
All right.
Okay. Okay. Thanks for stopping by.
Thank you so much, Professor. Have a good night. Bye.
Two.